We're going to look at the steps to get our bootstrap confidence interval construction done with inzight and how we will interpret what we're seeing. So we first go down and choose the bootstrap confidence interval construction, and we ask it to run selected VIT module. We've got to import data like we normally do. And I'm just going to use the LBM data on my desktop. There it is. So this is the lean body mass data, and then I need to select a variable. So I'll do what I normally do, which is select gender, and something crazy comes up which you can just ignore, and then I'll select LBM. So we've got our data selected. So this is our sample up above here in the blue and the red. This is the female sample of data and a male sample from the population. And now we're going to do the analysis. We're going to pick median. I mean, we could do mean, but median is nice because when we do median and then we hit record my choice, inzight will produce a box plot because the median is contained within the box. And it will show your medians for your females and your males. And the arrow that you see, the red arrow, is how much bigger, basically, the males' median LBM is than the females. It's about 19.58 kgs, that's the units that we're dealing with, bigger than females. And we want to basically create, what we're going to do is create a confidence interval between those distances, because we know that these medians, that's the sample, but we're going to resample. And when we resample and pull out and replace another 30 or 100, sample size, whatever it happens to be, then we know that our medians are going to shift and be different. And so that difference, that space between the female's median and the male's median are quite different. So what you're seeing here, let's just recap. You're seeing at the very top, you're seeing a sample. You're seeing a resample down below it in the blue and the red of the females and the males. And you will see from the box plot that the medians have changed, and so that red arrow, that distance, has changed. Now if we did 5 and we resampled for 5, we can see now that we're starting to build a confidence interval and that the medians have changed. And again, that distance, that arrow, that red arrow, will change each and every time. And if we do 20 and go, so now we've done 20 resamples. We're creating different medians every time we sample, and that arrow is changing. It's changing its distance and so on every time. But it's always pointing so that the males, in this case so far, are always greater than the females. This median is always, that distance is always positive, it's always greater. The arrow is always pointing to the right. Let's do 1,000 and see what happens. It takes a minute, but if we do 1,000 resamples, that arrow is changing its distance every time. The medians are changing. And you're building a confidence interval, but you're also building like a confidence interval for the distance as well, because as those medians between the females and the males changes, so do the arrows. So now you've got a confidence interval for the females, which is quite closely packed, by the way, much less variation in that confidence interval. And then down in the males, in the blue, you have a confidence interval, and you'd see that the arrow, the distance between these, is different every single time. Now, we're going to then go down to include bootstrap distribution, which is the next part of this. And if I said just do 1 repetition, it's going to drop that distance between the medians of the female and the male down, and it's going to write that as a dot on the bootstrap distribution. And that dot represents that distance between the two medians. And if I do it again, it drops down another point. Again, that is the distance between the medians. And again, it's just recording, as we resample, it's recording the change in the distance. And so every arrow is then represented as a dot. That's the distance between the males and the females. And if we were to do 1,000 of those, we get a distribution. All these arrows, if you notice up above, are all pointing to the right and are all showing that the male, every single time, has a bigger LBM than the female. Now, the difference changes, but males are always having a higher lean body mass than females. That arrow is always positive. When it's done, it will show you the distribution, and it will give you a confidence interval of that distance between the male and the female medians, and it will give you a confidence interval. Now, if that confidence interval is basically saying that males on average are between 16.27 and 22.89 kgs higher than the LBMs of the female. It's between that and that. But it's always positive. The arrows are always pointing in the right direction. So there's never a time when that is going to change, when females are, in fact, have a higher LBM. And the fact that it never happens for females to be higher, then we'll have no zero in that confidence interval. When we have no zero in that confidence interval, then we can go ahead and say it seems pretty likely that back in the population, males will have a higher LBM than females.